All right, guys, so we're starting 17.3 today. We're going to add, subtract, and multiply radicals. Before we start, I just want to show you a quick example. Let's say I had 5x plus 3x. Well, we know 5x plus 3x is 8x. They both had x, so we could add them together because they're like terms. But if I had 5x plus 3, we couldn't do anything. So the reason we could is because we had similar x values. That's the same thing that happens when we're adding and subtracting multiple radicals. So what I'm going to do is look at my factors here, and I'm going to go ahead and underline anything that has the square root of 3 at the end. Those can be combined. That square root of 3 is like having the same x. There's a 1 in front of here, so I take 8 plus 1, and I get 9 square roots of 3. So remember, the square root of 3 is like our x. It doesn't change. Now I have two more. I have plus 4x squared minus 1 square roots of 2, 4 minus 1 is 3 square roots of 2. That is your answer. So when you're doing these, it's just like combining like terms. Now the next one is very similar, except for it has things like square root of 12 and square root of 75 that we can simplify. So I have 5 square roots of 3. That doesn't change. Plus 4 times. I'm going to factor the square root of 12. I can divide it by 2 and get 6. And I can keep going and get 2 and 3. So 2 times 2 times 3 is 12. So the square root of 2 times 3. Minus 2 times. Now we have to factor 75. And guys, we've done these numbers before. I can take out a 5 and I'm left with 15. I can take out a 5 and I'm left with 3. They're the prime factors of 75. 3 times 5 times 5. Now our whole point of factoring is to find groups so we can take them out. In this first one, I have a group of 2's. So I have 5 square roots of 3 plus 4 times 2, because I can take out a 2, but the 3 is left inside. Same thing on the other side. I have negative 2 times. I can take out a 5, and then the 3 is left in the square root. So now we can clean that up. That's 5 square roots of 3 plus 8 square roots of 3 minus 10 square roots of 3. And since we have the square root of 3 on the end of all of them, basically I'm just dealing with 5 plus 8 minus 10. 5 plus 8 is 13, minus 10 is 3, square roots of 3. So that took a little bit more work, guys, but it's just because we're factoring those numbers and breaking them down. You might look back at previous notes when you see some of these numbers, because we may have factored them already, meaning you wouldn't have to do it all over again. Let's look at number 3. This is multiplication. It's actually a little bit easier. What we're going to do here is we're going to take our outside numbers and multiply those together. 3 times 5. Then we're going to take our square roots and multiply those together. Oops, square root of 2. 3 times 5 gives me 15. And then I have the square root of 6 times 2 is 12. Now I don't want to leave it like that because we already factored 12. I know that's 15 times the square root of 2 times 2 times 3. So I can pull out a 2. So I have 15 times 2 square roots of 3, which is equal to 30 square roots of 3. So see, we didn't have to factor that 12 again because we'd already done it. So pay attention. See if you can do that. Now the next one. We have a lot of problems with squares. This is 2 square roots of 3 squared. That means it's 2 square roots of 3 times 2 square roots of 3. And once you do that, it looks exactly like the last problem. I'm going to take 2 times 2, and I'm going to get 4. 3 times 3 gives me the square root of 9. But we know what the square root of 9 is. It's 3. So I have 4 times 3, which is equal to 12. So guys, multiply your outside stuff, multiply your inside stuff, then see if there's anything you can do to fix your square roots. All right, so we got 3 and 4 done. Let's go ahead and look at number 5. Now, number 5 and 6 are a combination of adding and multiplying or subtracting and multiplying, but essentially, it's just a distribution problem. So I'm going to have the square root of 3 times the square root of 2 plus the square root of 3 times the square root of 5. Now I do just like we done the last one. I multiply what's inside my square roots. So 3 times 2 is the square root of 6, plus 3 times 5 is the square root of 15. I can't factor those out anymore. 6 is 2 times 3, 15 is 3 times 5. So that's all I can do, and I'm finished. Now 6 works the same way. It's a distribution problem again. I have 3 square roots of 2 times 3 square roots of 8. And then I'm going to have minus 3 square roots of 2 times 4 square roots of 3. Now we just do our multiplication. 3 times 3 is 9. 2 times 8 is 16. Minus 3 times 4 is 12. 2 times 3 is 6. The only thing I can do now is we know what this one is. That's 4, so it's 9 times 4 minus 12 square roots of 6, which is 36 minus 12 square roots of 6. So guys, it's not the most complicated thing in the world. You need to practice these. If you do, it'll be really easy. If you don't, you're just going to forget it. If you have any questions, just come and let me know.